Hi everyone, thank you for joining. In this video we're going to solve another interesting integer equation. So we have PQR integers and we're given this equality and we want to find the values of PQ and R in integers such that it will satisfy this equality. So if you'd like to pause the video, try it yourself first, then we could go over it together. Right, so let's first rearrange it. In other words, we write p squared minus pr is equal to q squared minus pq, right? And if we factorize it, p into p minus r is equal to q times q minus p. Let d be GCD, greatest common divisor of pq. That implies p is equal to AD and q is equal to BD, where GCD AB is 1. And from this information, we can deduce that Q minus P must equal to Ka and P minus R is equal to Kb, where K is an integer, some integer, right? If it's not clear to you how we can establish this result, well, simply we've defined P to be that and Q to be that. So if you plug that into the first equation, we're going to have AD P minus R is equal to BD Q minus P. Now if we cancel these, we have A P minus R is equal to B Q minus P. And we have P minus R here and Q minus P there if you plug it in. So we have A K B here and B K A there. So they are the same thing, right? So in other words, these two are justified. Now, because we have Q minus P, Ka, well, Q is equal to dB, that's how we defined it, and P is dA, that's equal to Ka, right? So that implies dB minus A is equal to Ka. Since GCD of AB minus A is the same as GCD of AB, which is equal to 1, that implies that B minus A must divide K, right? And if that is the case, that implies K must equal to some integer times B minus A, right? So from here, that we have dB minus A is equal to Ka, and if we plug that in here, we're going to have dB minus A is equal to A times MB minus A. So that implies D is equal to AM. Now to begin with, we defined P to be AD and Q to be BD. So let's write it down. P is AD and Q is BD. Using this, we can rewrite these solutions as P is equal to A squared M and Q is equal to ABM, right? And we also had that P minus R is equal to KB. That implies R is equal to P minus KB. Now, if we plug in K, so we had K to be that, so let's plug it in here. That will give us R is equal to P minus, instead of K, B minus A, B, right? So we will have R is equal to P minus MB squared plus AMB, right? But we know P is that, so R is equal to A squared M minus MB squared plus AMB. So if we write it neatly, we will have P is equal to, let's write M, A squared, Q is equal to M times AB, and R is equal to, if we factorize it, let's take M outside, we will have A squared plus AB minus B squared. Okay, so this is the solution set for this question. So let's consider a very simple example. M is equal to A is equal to B, and let that be 1. So that means P is equal to 1, Q is equal to 1, and R is equal to, we will have 1 into 1 plus 1 minus 1. So that will just give us 1 as well, right? So in other words, the equation p squared plus pq is equal to q squared plus pr. We will have 1 plus 1 is equal to 1 plus 1 as expected, right? If we let's pick any other random numbers. So let m be a is minus 1 and b is 2, right? So that means we will have p is equal to 2a squared. So it's 2 times minus 1 squared, which is equal to 2. Q is equal to m times ab. So that's minus 2, which gives you minus 4. And lastly, r is equal to 2 times minus 1 squared, that's 1. Minus 1 times 2, that's minus 2. And minus b squared, that's minus 4. So that will give us r is equal to 2, it's minus 5, right? So r is equal to minus 10. Now let's check the relation. So we have p squared, which is 4, plus p times q, which is 2 times minus 4. All right, is it equal to q squared, which is 16, plus pr. So p is 2 and r is minus 10. So let's simplify it. We get 4 minus 8. Is it equal to 16 minus 20? The answer is yes. Okay, well, I hope you found it interesting. I hope you enjoyed it. Thank you very much for joining, and I look forward to seeing you in my future videos. Thank you.